Geopolymerization is a process that turns waste material into strong building material. To make it work well, we need to look at several things: the type of raw material, how we mix and cure them, their strength, environmental impact, cost, how they will be used, and whether the process is safe and scalable. Now, coming to our next slide, which is the about the technical feasibility and scalability. So for geopolymerization to work in real life, it must be repeatable and safe. We need technology that can produce the same quality every time. Also, we must handle chemicals like alkaline activators carefully to avoid risk. Now, coming to the very important informative slide about silica alumina ratio, here it need to address properly. The silica alumina ratio tells us how much silicon and aluminum are in the mix. So a lower ratio makes the structure more rigid but harder to work with. A higher ratio keeps helping with the strength and reactivity. So the best range is usually between 2 and 3. So we need to remember between 2 and 3 is the best. And now coming to the microstructural impact, where we can see that uh, when we increase silica alumina ratio, the material become denser and stronger. It forms a tight network that improves durability. But too much silicon can cause problems like poor mixing and weak spots. Now, coming to the adding calcium changes the type of gel that forms. So, low calcium gives us NaSH gel. More calcium create CSH or CaSH gel, which are stronger and set faster. But too much calcium can hurt the structure. This we need to remember. Now coming to the size of particle, that is very important. We can say alternatively particle fineness. So a smaller particle react faster and make stronger geopolymers. They help form a dense structure. Bigger particle don't react well and can weaken the final product. Now coming to the most important part, which is about a water helps break down a raw material and build the final structure. The silica alumina ratio affect how water is used. More aluminum means more water is trapped in the gel, while more silicon makes the structure tighter and less porous. So these all delicacies, this helps in understanding the material better way. Water content changes with the silica alumina ratio. More aluminum attract water, making the material more porous. More silicon makes it stronger and less water absorbing. Water also helps form strong bonds during the reaction. Geopolymerization means here how it works, that is dissolution. Dissolution especially stand for alkali breaks the raw material into small pieces, that is oligomer formation. This is what we are talking about, oligomer formation. These pieces form chain or rings. Polycondensation means the chain link into 3D network, and xylation, that is the network hardness and become solid. So all these intricacies of this chain links will gives us more idea about understanding the things better. Now coming to the strength behavior, which is also very important, and in these we know that the strength increases with silica alumina ratio up to about 2.0. After that it may drop. So low ratio makes weak structure, high ratio gives strong bonds but can cause mixing problems. So more strength develop in the first 7 days, and this also we need to aid in memory these criterias. Now coming to this table, which shows the everything at a glance, that is from raw material to mix design to strength and safety. It helps us understand what makes geopolymerization successful and how to apply it in real project.